Welcome to helpyourmath.com. My name is Sean, and in this video I'm going to explain how to rewrite a number in its scientific notation form. Now, in scientific notation, all we're doing is rewriting the number with a power of 10 in it. So, for example, we have 3,692. In scientific notation form, 3,692 would be 3.692 times 10 to the power of 3, so 10 cubed. Now, in scientific notation, the decimal point has to go after the first non-zero number from the left. Now, this non-zero part I'll explain more later, but basically it has to be after a number between 1 and 10 that's non-zero basically, and starting from the left. So in 3,692, 3 is the number closest to the left. So 3, so we place the decimal point right after the 3, and we count how many times we have to move the decimal point so that it changes back to our original number. So 1, 2, 3. Decimal point goes right here afterwards. Therefore, the power of 10 should be 3, since we're moving decimal 3 times, multiplying by 3 tens. Now, let's look at a negative exponent example. So we have 0.0000626. To convert this decimal into scientific notation, it would be 6.26 times 10. Now let's determine the exponent here. So the decimal point is after the 6, the first 6, so we have our decimal point here. We move it 1, 2, 3, and 4. So it'll be 10 to the negative 4th. Now, if we're moving the decimal to the left side, then we have a negative exponent. If we're moving it to the right side, then we have a positive exponent. Now, here's where the non-zero part, the first non-zero number part, comes in. Now, if we have a decimal like, for example, 0.000000568. Now, how do we know where to put the decimal then? We put it after the first non-zero number between 1 and 10. So in this decimal, the first non-zero number from the left is 5. So we start here. So we know the scientific notation for this. The first decimal will be 5.68, because 5 is the first non-zero number between 1 and 10 from the left. And we count how many times it moved. We have to move it to the left. How many times? So 1, 2, 3, 4, 5, 6. Since we move it 6 times to the left, we multiply by a power of 10 to the negative 6. Now, let's look at an example of 10 to the power of 0. Now, we use 10 to the power of 0 when we have a number like 5.8, where the decimal is already after the first non-zero number from the left. So 5 is the first non-zero number from the left. That's between 1 and 10. So therefore, we just rewrite it as 5.8 times 10 to the power of 0. Now, we are still following the rules of scientific notation because we're still including a power of 10 over here, which is 10 to the power of 0. And we're still getting our original answer, which is 5.8, because 5.8 times 10 to the power of 0, which is 1. 10 to the power of 0 is, anything to the power of 0 is always 1. This will equal to 5.8, which is our original. Now, we saw 3 possibilities of scientific notation. The first one is using a positive exponent, in this case 3. We have to move the decimal 3 times to the right to result back in our original number. We have a negative over here where we have to determine how many times we have to move to the left to get our original number. So over here, from 6.26, we move it 4 times to the left, 1, 2, 3, 4, to get back to our original number, which is 0.000626. Same thing with 5.68 times 10 to the negative 6 power. And finally, for 10 to the power of 0, we use it when our decimal or number is already in its scientific notation form, which is the decimal after the first non-zero number between 1 and z. And over here, 5.8 is already in its correct form for scientific notation. Therefore, we just multiply by 10 to the power of 0, resulting in 5.8 times 1, which is 5.8. Thank you.